Okay, we're going to take a look at 9.1, estimating a population proportion. And so I wanted to give you a little bit of background here. A point estimate is the value of a statistic that estimates the value of a parameter. So let's take an example here. Suppose you are asked to estimate the proportion of Jackson State students who work more than 30 hours per week. Well, again, if we assume that the population, capital N, of Jackson State is 4,000, roughly, then we would have to survey all 4,000 students. Well, instead of doing that, let's take a sample of maybe 100. Okay, this value down here, sample proportion, is what we call a statistic. And this statistic here, what it does is it estimates the true value. So this value here estimates the true value. We'll do it in yellow. And so you learned at the beginning of class, this is called a parameter and this is called a statistic. Now, I actually did this. Now these three samples are actual samples from my class. And I asked about 25 students here. We'll assume 100 here. Do you work more than 30 hours per week? So the first person said, yes, I do. No, I don't. And then the 100th person said, no, I don't. And I did another sample in another class of mine. And I found out that roughly 28% said that they do. So here we have a statistic, and a statistic, and a statistic. And you can see all three of these, based on the three classes that I surveyed. Roughly, we can assume now, roughly, since this is 31%, 28%, roughly about 30% of students at Jackson State will work more than 30 hours a week. Now, the idea behind a confidence interval is instead of reporting a single number, what we do is we report an interval of numbers. So we might report something like 30% plus or minus, and we call this value here in purple. We call this the margin of error. So 38 plus or minus 2% would take us to 28 to 32%, and we might say that we're 80% confident that the true value, right, the true percentage of students is somewhere in between this interval. Okay? Now, if the confidence goes up, right, then that means that the interval is going to do what? Think about it. Get smaller or get wider. Well, if the confidence goes up, then the interval must get wider, right? I mean, think about it like this. How confident would you be to say that the true proportion of students at Jackson State who work more than 30 hours a week is somewhere between, we'll say 1%, all the way up to 99%, right? How confident would you be that the true percentage would be, well, I mean, gosh, we know that it's somewhere around 30%, so we're really confident that it's going to be in here. And that's kind of the logic. The more confident that we are, the logic says the wider the interval must be. Okay? Now, to construct a confidence interval, you check the two conditions here, which again, they will always be met. You don't have to worry too much about those. And so the lower bound, right, you're going to have a lower bound and you're going to have an upper bound. And the lower bound, if we do this by hand, I'm going to show you how to do this with technology to speed things up. But the lower bound would be calculated here, and the upper bound would be here. And I'm just telling you that the margin of error, okay, the margin of error is this guy. So this is the margin of error, and it's the same for the lower and upper bound. Now, if you do this by hand and you look up Z alpha by 2, notice you need 3 things to compute this by hand. You need the sample proportion p hat, you need Z alpha by 2, and you need n. And all those will be given. So let's take a look at an example. In a survey of 3,611 adult Americans 18 years and older, conducted in July 2010 by Smart Revenue, it was found that 542 have used their smartphone to make a purchase. Part A, obtain a point estimate for the population proportion of adult Americans 18 years and older who have used their smartphone to make a purchase. So, point estimate. I'm doing this in blue. Is equal to x over n. X would be 542. N would be 3611. 15%. Now verify the requirements, and again 0.15, 1 minus 0.15 times the sample size. You can check these. These are not that big of a deal. Now, construct a 90% confidence interval. So for this one right here, I'm going to show you for 9.1, we're going to use the calculator. And what we're going to do is we're going to go to Stat. We're going to go over to Test. And we're going to arrow down until we see one prop Z interval, this one right here. And you'll see that it asks us for 3 things: X, which we already have. We have X, which is 542, and we have N, which is 3611. And we want 90% confidence. So X, which is 542, and then N, which is 3611, and then the confidence is 0.9. Calculate, and here we have our interval. So 1403 up to 1599. Now interpret the interval. Here's what we say. We say we are 90% confident that the true population proportion of people who make purchases on their smartphones is somewhere between 14.03% and 15.99%. And on the exams, I want you guys to be able to interpret exactly in this fashion here. Okay, one more example here. A random sample of 1,003 adult Americans was asked, do you pretty much think televisions are a necessity or luxury you could do without? Of the 1,003 adults surveyed, 521 indicated that televisions are a luxury they could do without. Obtain a point estimate for the population proportion of adult Americans who believe that televisions are a luxury they could do without. So again, point estimate. 521 said they could do without televisions. Over 1,003. So we get 51.9%. Okay, that's our point estimate. Check the conditions. You can see once we get p-hat, we can check the conditions. Construct and interpret a 95% confidence interval for the population proportion of adult Americans who believe that televisions are a luxury they could do without. So again, we're going to go over here and enter x over n. So go back to stat, go over to test, and we're going to stop at 1 prop z interval. We're going to enter x, which is 521. We're going to enter the sample size, which is 1,003. And our confidence level, in this case, we want a 95%. Calculate. Okay, so we get 4,885. This is our lower bound. And the upper bound is 5,504. Okay, part D, is it possible that a supermajority, more than 60% of adult Americans believe that television is a luxury they could do without? Well, this interval says that we are 95% confident that the true proportion that we call x over n, capital N. We are 95%. The true proportion is somewhere in between here, which if you notice, this interval does not include 60%. So is it possible? Yes, it is possible, right? It's possible that that would be true, but it's not likely. Okay, so is it likely? No, would not be likely. Now, so why don't you pause? I want you to pause the video now and see if you can try part E. And I'll be back in a moment. Okay, so hopefully you were able to get the interval. Okay, and the only thing again that changed was the confidence. You went from 95 to 90. Now let's turn to the question of sample size. In a Gallup poll conducted October 2010, 44% of the people polled answered more strict to the following question. Do you feel that the laws covering the sale of firearms should be made more strict, less strict, or kept as they are now? Suppose the margin of error in the poll was 3.5% and the estimate was made with 95% confidence. At least how many people were surveyed? So basically this question of sample size, basically we specify a margin of error and a level of confidence, and we want to know what should the sample size be to estimate the true value within the margin of error. Within the margin of error with a certain level of confidence. Now there are two formulas that we're going to use here. One, if a previous estimate is available, it looks like this. And the other, when no prior estimate is available, and it looks like this. Z alpha over 2 divided by the margin of error squared. Now we have a prior estimate here of 44% back in 2004, so that's what we'll use here. We'll use the prior estimate. 1 minus now to get Z alpha by 2, we're going to look in table 5. Okay, so table 5. And down here you'll see confidence interval critical values. So we want to know what our level of confidence is, 95%. So let's go back over here and look. So the critical value will be 1.96. Margin of error, we always want to use this, convert this to decimal. Squared, don't forget the squared. You compute this and you get 772. Now here we always want to round up. So approximately 773 individuals were in the sample. Now if you have no prior estimate, then you use this formula here, which has this constant. So let's plug it in. Everything stays the same. Margin of error. We get approximately 784. Okay, see you guys in 9.2.